SAT, lesson number 12, transformations 1, 13 question mini set. Question 1. What is the location of the point 29 when translated by xy to x plus 7, y minus 4? Well, there's no graph for you, but by sketching it locally, you can see the starting point x will be moved 7 units to the right along the x-axis, and then down 4 units in quadrant 1. This will place the new point that was at 2, 9. 2 plus 7 is 9 for the x-coordinate, and 9 minus 4 is 5. So the new location will be at C, 9, 5. Here I added the computer circle, like start operation, and the red square for stop, to show you that the correct answer was C, 9, 5 for this translation. Question number 2, what is the location of the y-coordinate of the point 3, 4 when translated by xy, with x going 5 units to the left and y plus 8 or 8 units up? Well, as you can see here, again, drawing a quick sketch is a good way to do this. You're going to take the x-coordinate and subtract 5, so it'll be -2, and the y-coordinate 4 will be getting additional 8 units, and the new location will be at -2, 12. Since the question was, what is the y-coordinate? We're looking for the second number there because we labeled the ordered pair as x, y, and the correct answer is D, 12. Question 3. What quadrant is the point -5, 4 when translated by the rule xy to x plus 7, y plus 5? So we're starting at -5, we'll add 7 units, and x-coordinate will be 2. We're starting at 4, and we're adding 5 units, so the y-coordinate will be 9. That will move the point from its location in quadrant 2 across the y-axis line into quadrant 1. Remember that the quadrants positive is quadrant 1, but that they're labeled counterclockwise. So that was quadrant 2 of the pre-image -5, 4 for question 3. Correct answer was A, quadrant 1. Question 4. If f of x is x cubed plus 1 and g of x is f of -x plus 1, what is the location of g of -2? Well, here we have a composition of 2 functions, which is a type of transformation. So this is a little different, but it is included on the SAT exam. For this composition of functions, we follow rule G, plugging in -2, which, because we're doing f of negative that value, will evaluate f at 2. Well, f is the rule to take the number, cube it, and add 1. So we have to take the number 2 and cube it and get 8 plus 1 is 9. Then add 1 additional unit to that for function g of x, and we get g of -2 is 9 plus 1 or 10. And we have the point x comma g of x being x is -2 and will be at 10 on the Cartesian plane. So the correct answer was D, -2, 10. Question 5. If f of x is x cubed plus 1 and g of x is f of -x minus 2, what is the y value of g of 5? So similar to the previous problem, here we're going to plug in 5, but then we have to evaluate f of -5. Well, we have to cube the number and then add 1. So -5 times -5 times -5 is -125, plus 1 is -124, minus 2 is -126, and the correct answer was C, -126. So if you plug in x equals 5, it will map to -126 for composition for function g of x. Question 6. What is the location of A3, -4 reflected over the x-axis? Well, A3, -4 is down there in quadrant 4, and I've squared it off with a rectangle to space it out. But the mirror line is the x-axis reflection. So the distance to the mirror is 4 units. So the image will be 4 units away from the mirror on the opposite side of that line. We're looking down from above on the mirror. So therefore, A prime, the image, will be at 3, 4, and the correct answer is A for this x-axis reflection. Question 7. What is the correct graph translating x squared plus x minus 2 to the left 2 units and then down 2 units? Well, I took the liberty of drawing the 7-point parabola for this graph, which you can see here is underneath the text for number 7. Those are 7 local points that can easily be mapped quickly. If you want, you could just graph the roots and move them as well, following the translation step, t minus 2 and minus 2. Well, that's what I'm going to do just with 3 local points, like this triangle of points. So here I moved the 2 roots to the left 2 units and down 2 units. And then I took the vertex point, negative 0.5, 2.25, and I also moved it down. So that means that those 3 points on the parabola are certainly going to be translated to those locations. Those triangle of points will go where those red squares are. Next, you can quickly sketch the same shape parabola as a quick sketch, and the only one that matches having the vertex in quadrant 3 down there, and would be choice B. The correct answer was B. So here I moved a triangle of 3 points from my 7-point parabola using that translation, x minus 2, y minus 2. Question 8. The graph below is the function f of x equals x cubed minus 6x squared plus 11x minus 6. Which of the choices is the graph f of x plus 2? Well, here, whoa, why did it just skip? Sorry, that was question 8. So here, since it's just the original function above and we're lifting it up 2 units, the correct answer is D. That's the only graph that's lifting it vertically upwards on the map. Every point is mapped 2 boxes higher. So correct, choice D is correct. Question 9. The graph below is the function f of x equals x cubed minus 6x squared plus 11x minus 6. Which of the choices is the graph f of negative x? Well, here I figured out that, well, if I plug in x equals 0, then it'll be 0 minus 0 plus 0 minus 6. So the y-intercept is at negative 6. And then I also figured out if I plug in x equals 1, I just tried, I plugged in x equals 1, and then we get 1 minus 6 plus 11 minus 6, which is 0. Also, if you plug in x equals 2, believe it or not, that's the next root, the next crossing point, and x equals 3. Well, since x is being shifted to negative x, whatever is at 1 will then be mapped to negative 1. Whatever is at 2 will be mapped to negative 2. Whatever is at 3 will be mapped to negative 3. This is a y-axis reflection. It's being flipped over like you would fold it over, like folding origami paper or folding like a symmetry drawing in biology class or in a life science or in art class when you want to fold over an image and press it so that it has the symmetry line at the y-axis. So that's the math code for that on the Cartesian plane. Whatever x values are 1, 2, 3 are now negative 1, negative 2, negative 3 in reverse order. And the y-axis is the middle, is the mirror line. So the correct answer is C. That is the correct opposite wing, the opposite function for this cubic. Question 10. The point A, which is at negative 5, 2, is reflected over the y-axis. Okay. Then it's reflected over the line y equals 3. That's the second move. And then the third reflection is the transformation over the x-axis. Okay, that transformation is the x-axis. So I think I drew that as, here it's in quadrant 2 because it's negative 5, 2. That's point A. And I drew that with a green circle. And there's the first move. And it would stop at 5 units on the, it would move from quadrant 2 to quadrant 1. Reflecting over the y-axis. Then it would move, and I called that A prime. Right. Then to get to A double prime after the second image would be at, well, it's 1 point to the mirror and then another unit above. So that would move it to 5, 4. Then since we're going 4 steps to the mirror here, or the x-axis, the third image, A triple prime, will be at negative 5, 4. We'll move down to quadrant 4. And the correct answer was B, 5 comma negative 4. Wait, why did I write that wrong? Oh, I got to fix that. You see that? For some reason, that's the wrong point. Here, I'll cover that with a black card. Excuse me for number 10. That should say 5 comma negative 4. All right, let's put that on properly. All right, so that's the right tag for the final location. The correct answer is B. So the x coordinate was positive. We're in quadrant 4. Okay, next question. Question number 11. Now we have 3 grid ends, so we have easy level. If point A is at 5, 2, point B is at negative 1, 2, and you relocate it to negative A prime B prime using the translation, TXY equals 10 units to the left and then up 4 units. What is the distance A prime B prime? Well, think of like a bookshelf in the library, right? And the book is here, but the book is out of place, right? So we're like, oh man, it doesn't belong in this section. Someone like just dropped it off here. So then you'd pick up the book with the Dewey Decimal System. You'd walk over here, right? And then it belongs up here on this shelf. But however, the ends of this shelf here, well, it's 6 units because from negative 1 to 5, that's 1 unit to the y-axis, right? It's 1 and then 4 units to 5 units. So that 1 plus 5 is 6 units is the length of that bookshelf, say. Right? But then if we're moving something from there and it belongs really on this shelf, well, it's the same piece of wood, like they're the same. So it's also 6 units from B to A. So for this isometry, you know, the distances are preserved. It's not like dilated. Okay, so it's move them separately. Okay, so A to A prime, the distance between A prime and B prime will be the same as the original segment. Okay, question 12. If point A 6, negative 2 is relocated with a reflection over the y-axis, what is the y coordinate of the new point? Well, here, the y-axis is the vertical line. So if that's the mirror, it's 6 units to the mirror, 6 units on the other side. And now both coordinates are negative. The y coordinate will be negative 2. So make sure you bubble with negative 2. Okay, so you have to extract that detail from the STEM question. Last one, question 13. Let the exponential function f of x equals log 2 to the x, when reflected over the line x equals y, forming the function g of x. What is the value of g of 3? Well, you have to know a little bit about logarithms as being the exponents that we're trying to find. So be careful when you read a log. This is the log, f of log base 2 of x, which means that the bottom of the exponent is 2, but we want to figure out what exponent we need to reach, say, 8. So I'll draw it on the map. So if the base of the exponent is 2, and we want to reach 8, we need 3, right? If the base of the exponent is 2, and we want to reach the number 4, which is on the x-axis, we need an exponent of exactly 2. If the base of the exponent is 2, and we do 2 to the 1 power is 2, we want to reach the number 2. So in reverse, if you flip over the line x equals y, we'll have these points. Instead of 2, 1, we'll have 1, 2. Instead of 4, 2, we'll have 2 maps to 4. Instead of 8 mapping to 3, we'll have 3 maps to 8. So if you've already taken algebra 2, you know that the inverse function is the function that's reflected over the line x equals y in this design. So that means that these are related. The log is the exponent we're looking for, but that's based on an exponent function. These ones are easier to say in English. G of 3 would mean that the base is 2 and the power is 3. So just plug it in, and 2 to the 3rd power would be 8, which is this point here. And that is the value of function g, which is the exponential. So I'll say it one more time. This is the original function, the log, but the reflected function is the inverse, which is the exponential. So they're reflections of each other. They're inverses of each other over the line x equals y. Inverse functions. So the log is the inverse of the exponential function 2 to the x. When we have our logarithm review class, we'll go over more of this at a later time. So I do hope that this video was useful to you in understanding the idea of reflections. Since x equals y, you just swap the coordinates. And again, thank you for studying with me for your SAT prep. And thank you for watching my video.